Question number 1. A media storage application uploads user photos to Amazon S3 for processing by AWS Lambda functions. Application state is stored in Amazon DynamoDB tables. Users are reporting that some uploaded photos are not being processed properly. The application developers trace the logs and find that Lambda is experiencing photo processing issues when thousands of users upload photos simultaneously. The issues are the result of Lambda concurrency limit and the performance of DynamoDB when data is saved. Which combination of actions should a solution architect take to increase the performance and reliability of the application? Choose 2 answers. Question number 2. A company has applications in an AWS account that is named source. The account is in an organization in AWS organizations. One of the applications uses AWS Lambda functions and stores inventory data in an Aurora database. The application deploys the Lambda functions by using a deployment package. The company has configured automated backups for Aurora. The company wants to migrate the Lambda functions and the Aurora database to a new AWS account that is named Target. The application processes critical data, so the company must minimize downtime. Which solution will meet these requirements? Question number 3. A company is building a serverless application that runs on an AWS Lambda function that is attached to a VPC. The company needs to integrate the application with a new service from an external provider. The external provider supports only requests that come from public IPv4 addresses that are in an allow list. The company must provide a single public IP address to the external provider before the application can start using the new service. Question number 4. A company wants to run a custom network analysis software package to inspect traffic as traffic leaves and enters a VPC. The company has deployed the solution by using AWS CloudFormation on 3 Amazon EC2 instances in an auto-scaling group. All network routing has been established to direct traffic to the EC2 instances. Whenever the analysis software stops working, the auto-scaling group replaces an instance. The network routes are not updated when the instance replacement occurs. Which combination of steps will resolve this issue? Choose 3 answers. Hello everyone. I am Rafi Saeed and I am excited to welcome you to another insightful 591 Lab video. Today our focus is on AWS Solution Architect Professional Exam. Whether you are preparing for the SAP-C02 exam or you are a cloud architect or system admin, this video is tailored to provide you with invaluable insights. Before we dive into the content, we kindly request you to subscribe to our channel, give this video a thumbs up and hit the bell icon. Your support empowers us to produce more valuable content like this, helping you excel in your cloud journey. Today's session revolves around AWS Lambda, where we will explore its significance and how to set it up effectively. Following that, we'll review exam questions to ensure a comprehensive understanding. But before we get started, let me provide you with a brief overview of what 591 Lab is all about. 591 Lab is a top IT training and certification exam brand in China, Hong Kong, Taiwan, and Singapore. Our mission at 591 Lab is to provide our clients with exceptional exam preparation experience for certification in AWS, Cisco, Huawei, Aruba, Juniper, Palo Alto, and Fortinet exam tracks. Today we have an exciting agenda lined up. First we will discuss AWS Lambda, explaining key features and benefits. Then we will discuss a real-time image processing solution in the AWS cloud. After that we'll do a practical walkthrough in the console to show how it all works. Once we are done with that, we'll review the key takeaways to ensure comprehension. Finally, we'll wrap up by tackling some exam-style questions together. So let's dive in and get started. So, what is AWS Lambda? AWS Lambda is a serverless computing service provided by AWS that allows you to run code without provisioning or managing servers. It enables you to execute code in response to events triggered by various AWS services or HTTP requests. With Lambda, you don't need to provision or manage servers. AWS automatically manages the infrastructure, including server provisioning, scaling, monitoring, and maintenance, allowing you to focus on writing code. Lambda functions can be triggered by various event sources such as changes in Amazon S3 buckets, updates to Amazon DynamoDB table, incoming HTTP request via Amazon API Gateway, messages from Amazon SNS or SQS, and more. Lambda supports multiple programming languages including Node.js, Python, Java, Go, .NET Core, and Ruby, allowing you to write functions in your preferred language. Lambda automatically scales to handle incoming requests and events from a few requests per day to thousands of requests per second, without any manual intervention. Each invocation of a Lambda function runs in isolation, allowing for horizontal scalability. With Lambda, you only pay for the compute time consumed by your functions. Measured in milliseconds, there are no upfront costs or minimum fees. You are not charged when your code is not running or idle. Lambda functions are automatically deployed across multiple availability zones within a region for high availability and fault tolerance. AWS manages the infrastructure and ensures that your functions are always available. Lambda functions run within an isolated execution environment with fine-grained identity and access management permissions. You can control access to AWS resources and encrypt data using AWS KMS for enhanced security. Lambda seamlessly integrates with other AWS services, allowing you to build event-driven architectures and serverless applications using various AWS services together. For example, you can trigger Lambda function in response to events from Amazon S3, DynamoDB, SQS, SNS, and more. Lambda eliminates the need of server provisioning, maintenance, and monitoring, reducing operational overhead and allowing developers to focus on writing code. Lambda automatically scales to handle fluctuating workloads, ensuring that your functions can scale seamlessly to meet demand without manual intervention. This enables you to build highly scalable and responsive applications. With Lambda pay-per-user pricing model, you only pay for the compute time consumed by your functions, leading to cost savings compared to traditional server-based architectures where you pay for idle resources. Lambda enables development and deployment of applications, allowing you to iterate quickly and bring new features to market faster. You can focus on writing business logic without worrying about infrastructure management. Lambda events-driven architecture and integration with AWS services enables you to build flexible and agile applications that can respond to events in real time, enabling new use cases and workflows. Overall, AWS Lambda provides a powerful platform for building serverless applications, offering scalability, cost effectiveness, and agility while reducing operational complexity. This diagram illustrates the workflow for image processing within an AWS environment utilizing Lambda function. Users upload images to an S3 bucket named Image Bucket. This bucket serves as a trigger point. Whenever a new image is uploaded to Image Bucket, it triggers an event. Lambda is used for image processing. The Lambda function code responsible for handling image processing tasks such as resizing, cropping, or applying filters. When triggered by an event from the Image Bucket, Lambda retrieves the uploaded image for processing. Processed images are stored in another S3 bucket named Tint Images Bucket. A notification can be sent to subscribers via Amazon SNS to notify them about the completion of image processing tasks or any relevant events. This diagram provides an overview of the flow in a real-time image processing scenario, demonstrating Lambda's central role in processing uploaded images and managing interaction with other AWS services such as S3 and SNS. Let's proceed with the implementation of real-time image processing using Lambda to demonstrate how this can be achieved without the need for any server infrastructure. Alright, so we are logged into the console. In this lab, we will use two AWS S3 buckets. The first bucket will store the original images that we intend to resize, while the second bucket will be dedicated to storing the resized images. We will automate the resizing process using an AWS Lambda function, which will handle the resizing of images and upload the resized images to the second bucket seamlessly. I have already set up 2 buckets for this lab. This bucket will be used for uploading images, and this one will store resized images. Additionally, I have also created SNS topic that will send notifications once the uploaded images are resized. So now let's create a Lambda function that will help us to resize the images and store the images. Alright, so this is the AWS Lambda dashboard and we need to create a function. So let's click on create function, enter function name. Now choose the runtime. So there are a lot of options available. You can choose any preferred language as per your choice. As you can see, there are Python, Ruby, Node.js, .NET and so on. There are a lot of choices available. Alright, so we are going to use Python 3.9 for this particular lab. So this is our runtime. And for the permission, you can create a new role as per your requirement, or you can just select the basic Lambda permission. But in this lab, we are going to use S3 and SNS with Lambda, so we have to assign permission. I have also created an IAM role. Let me show you the IAM role I just created. So this is the role that we are going to use for this lab. I can show you the permissions as well. Alright, so as you can see, there are 3 permissions attached to this role. This is for S3, SNS and Lambda basic execution role. So this role basically store all the log files, all the log data whenever our function is triggered. So this particular log will store all the log data into CloudWatch logs. Let's jump back to the Lambda. Now let's create function. Alright, so the function has been created successfully. First thing first, we need to replace this code with our code. So we are going to use the following code. So this is the code we are basically going to use for resizing the images. And what we need to do, we just need to copy the whole code and paste into Lambda function. So let's copy the code. And Ctrl A and Ctrl V, paste it here and deploy it. Now rename the function name as per your choice. So I'm going to name it 591 lab and just deploy it. Now we need to configure a few things in the Lambda function. So let's start with runtime setting that is exactly under the code itself. So let's click edit and add the handler name according to your Python code name and save it. So my Lambda function code name is 591 lab. And my handler name is handler. So this should be look like this and save it. Also in our Python code, we have to provide our second bucket, which is stint images bucket name and SNS topic ARN. So we can paste the S3 bucket ARN and SNS ARN here, but instead of hard coding it, we can use Lambda environment variables and we will pass our information. Environment variables basically adjust your function's behavior without updating code. So creating the environment variable, we need to go to configuration and under environment variables, click edit, add environment variable. We can copy the keys from our code. So this is the key. Let's copy it. Add another variable as well. And copy this as well. So in the values, we have to paste S3 bucket name and SNS ARN. So let's copy the ARN first. So this is my SNS topic. Let's copy the ARN and paste it into Lambda. And same for S3 bucket. So this is the bucket we are going to use for resize images. So let's copy it and paste it here and just save it. Now we need to add PIL library. PIL is basically acronym for Python Imaging Library. You can prepare the package containing the PIL library for Python 3.9. So you will need to include the pillow package and its dependencies in it, and you can upload it here, like in the layers. So as you can see, I have already uploaded the PIL library, which we are going to use for this function, which will help us to resize the image. You can also create a virtual environment to install Pillow for Python and then package the contents of the virtual environment into a zip file and upload it into Lambda. So let's scroll down. First go to code. From here we can add a layer. So let's click on add a layer and click on specify an ARN, as we have already uploaded a layer into Lambda. So let's click on it and we need to paste the ARN. So we have to copy the ARN first. So let's quickly jump on layers and copy the ARN. This is the ARN which we are going to use with Lambda. So let's copy the ARN and go to functions. Click on add a layer. Specify an ARN. Paste it here and verify. And just click add. Alright, so finally we need to add a trigger for the Lambda function. So click on add trigger. So whenever someone uploads an image to the upload image bucket, which I showed you earlier, so the Lambda function will trigger and start the process of resizing and image and doing the other respective things. So let's select S3. So we are going to use this bucket, image upload bucket. Let's select it. Acknowledge and click add. So now everything seems to be configured. So it's time to test it. So for testing, we have to go to the code and click on test. So template name, we can set any name as per our choice. So let's name it test. And from template, just type S3 put, because we are going to upload image into the S3 bucket. So let's select it. Scroll down. Alright, so in the bucket name, we have to copy the bucket name which we are going to use for uploading images. So let's go to S3 and this is our bucket 1, image upload. Let's copy the name and paste it here. Also, we can specify an object name as well for testing purpose. So I have also uploaded an image into our S3 bucket. Let me quickly show you. So this is basically Lambda PNG file. So we can copy the name of object and paste it here into the object key. Alright, that's it. And just click on save. Alright, so before testing it, let me show you the second bucket as well, which is currently empty. So this is the bucket which is currently empty, as you can see there. Right, so let's back to Lambda and click on test. Alright, so the function is successfully executed. Now let's verify from S3. Let's refresh it. Alright, so as you can see, Lambda resize image is basically successfully stored into tinned image bucket. This bucket size is basically 4.9 kilobyte, and if you compare to the original image, this image size is basically 11.3. So the image is successfully resized. We can also verify by downloading both images. So let's download this image first. And now download the another resize image. Let's back to the bucket, click on tint images and download this one as well. Alright, so both images successfully downloaded. Let me show you the difference between both images. So this is the original image, which is around 11 kilobyte, and this one is the resize image, which is around 4 kilobyte. So you can see the difference here. So this Lambda function is basically successfully resized this image without provisioning any server. So we are going to upload few more images to test the function itself. So, but before that, let me show you the notification is also received. So let me pull the notification here. As you can see, so the notification is also successfully received, which indicates that this lambda.png image has successfully resized. Alright, so let's upload few more images and verify the whole process. Alright, so let's jump back to the upload bucket, which is bucket 1. Click on the bucket. These are the two images which I am going to upload one by one. So let's upload this or drag and drop this image first. Just upload it. Alright, so now let's verify this image is resized or not. So the actual image size is 10.8 kilobyte. So let's jump back to the tint image bucket. The image successfully resized, and the current size of this resized image is 5.2 kilobyte. Now do the same process with the remaining final number Lambda image as well. So jump back to the bucket. And now we are going to drag and drop this image. And let's verify within the tinned image bucket. Perfect. So this image is also resized, and the actual size of resized image is 10.7 kilobyte, and the original image size is around 32.7 kilobyte. Also, let's verify the notifications as well. So this is the first image notification, which is lambda.png, and as you can see, I have also received the notification for both processed images. So this one is basically for unnamed.png and this one is for the channel JPG. We have effectively deployed an automated image resizing system utilizing AWS S3, Lambda and SNS. This solution enables us to store original image in one bucket and automatically resize and store them in another. The incorporation of Lambda and SNS ensures real-time notification regarding the resize process. We have streamlined our image management workflow, boosted efficiency, and elevated the user experience. Today we have explored just one example of Lambda's capabilities, but it's a powerful tool with many potential use cases. So I encourage you to dive deeper into Lambda and explore its versatility. You can integrate it into various architecture to enhance functionality and efficiency. Now this is the end of the lab. Let's jump back to the slide. Alright, so here are a few key points which help you to leverage AWS Lambda effectively. AWS Lambda is a serverless computing service. It allows you to run code without provisioning or managing servers. Lambda functions are triggered by events from various sources, such as changes in data in Amazon S3 buckets, updates to Amazon DynamoDB table, HTTP requests via Amazon API Gateway, messages from SNS or SQS, and more. Lambda supports multiple programming languages including Node.js, Python, Java, Go, .NET Core, and Ruby, allowing you to write functions in your preferred language. Lambda seamlessly integrates with other AWS services, allowing you to build event-driven architectures and serverless applications using various AWS services together. Lambda can be used for a wide range of use cases, including real-time data processing, file processing, web and mobile backend services, IoT applications, machine learning, and more. Understanding these key points will help you leverage AWS Lambda effectively for building scalable, cost-effective, and agile applications in the cloud. Alright, so now we will review a set of exam questions and answers to deepen our understanding. Question number 1. A media storage application uploads user photos to Amazon S3 for processing by AWS Lambda functions. Application state is stored in Amazon DynamoDB tables. Users are reporting that some uploaded photos are not being processed properly. The application developers trace the logs and find that Lambda is experiencing photo processing issues when thousands of users upload photos simultaneously. The issues are the result of Lambda concurrency limit and the performance of DynamoDB when data is saved. Which combination of actions should a solution architect take to increase the performance and reliability of the application? Choose two answers. Option A. Evaluate and adjust the RCUs for the DynamoDB table. Provision read capacity unit determine the read throughput for DynamoDB tables. Adjusting the RCUs may improve the performance of read operations but may not directly address the issues with concurrent write operations during photo uploads. So this is not the correct answer. Option B. Evaluate and adjust the WCUs for the DynamoDB tables. Provision write capacity unit determine the write throughput for DynamoDB tables. Adjusting the WCU can help address performance issues related to saving data in DynamoDB, potentially mitigating the concurrency issues experienced during photo uploads. This one seems to be the correct answer, but let's discuss available options as well. Option C. Add an Amazon Elastic Cache layer to increase the performance of Lambda functions. Amazon Elastic Cache is an in-memory caching service that can improve the performance of application by reducing the load on backend services. However, adding Elastic Cache may not directly address the concurrency limits of Lambda functions or the performance issues with DynamoDB, so this one is also not the correct answer. Option D. Add an Amazon Simple Queue service and reprocessing logic between Amazon S3 and the Lambda functions. Adding an SQS queue can help manage concurrent requests and decoupling the processing speed of Lambda functions from the upload rate of photos to Amazon S3. This can improve the reliability of the application by ensuring that all uploaded photos are eventually processed. This one is also seems the correct answer, but let's discuss the last option as well. Option E. Use S3 transfer acceleration to provide lower latency to users. S3 transfer acceleration can improve the speed of uploading photos to Amazon S3 by leveraging Amazon CloudFront's globally distributed edge locations. While this may improve user experience, it may not directly address the issues with Lambda concurrency limits or DynamoDB performance, so this one is also not the correct answer. The most suitable combination of action to increase the performance and reliability of the application are option B and D. These actions directly address the performance issues with DynamoDB, write operation, and the concurrency limit of Lambda function during photo uploads, thereby improving the overall reliability of the application. Question number 2. A company has applications in an AWS account that is named source. The account is in an organization in AWS organizations. One of the applications uses AWS Lambda functions and stores inventory data in an Aurora database. The application deploys the Lambda functions by using a deployment package. The company has configured automated backups for Aurora. The company wants to migrate the Lambda functions and the Aurora database to a new AWS account that is named Target. The application processes critical data, so the company must minimize downtime. Which solution will meet these requirements? Option A. Download the Lambda function deployment package from the source account. Use the deployment package and create new Lambda function in the target account. Share the automated Aurora DB cluster snapshot with the target account. This option involves migrating the Lambda functions by downloading the deployment package and creating new Lambda function in the target account. However, it only shares the Aurora DB cluster snapshot with the target account, which might not ensure a seamless migration of the database while minimizing downtime. So this one not seems to be the correct answer. Option B. Download the Lambda function deployment package from the source account, use the deployment package and create new Lambda function in the target account. Share the Aurora DB cluster with the target account by using AWS Resource Access Manager. Grant the target account permission to clone the Aurora DB cluster. This option is similar to option A, but additionally shares the Aurora DB cluster itself with the target account using AWS RAM. Granting permission to clone the Aurora DB cluster allows the target account to create a replica of the database, ensuring minimal downtime during migration. Option C. Use AWS Resource Access Manager to share the Lambda functions and the Aurora DB cluster with the target account. Grant the target account permission to clone the Aurora DB cluster. This option shares both the Lambda functions and the Aurora DB cluster with the target account using AWS RAM. Granting permission to clone the Aurora DB cluster ensures that the target account can create a replica of the database, facilitating a seamless migration with minimal downtime. Option D. Use AWS Resource Access Manager to share the Lambda functions with the target account. Share the automated Aurora DB cluster snapshot with the target account. This option shares only the Lambda function with the target account and provides the Aurora DB cluster snapshot, which may not be sufficient for migrating the database while ensuring minimal downtime. After reviewing the option, it appears that option B and C most suitable for meeting the company's requirement. Both options involve sharing the Lambda functions and the Aurora DB cluster with the target account, ensuring a seamless migrating while minimizing downtime. However, option B specifically mentions granting permission to clone the Aurora DB cluster, which directly facilitates the migration process. Therefore, option B is likely the correct solution. Question number 3. A company is building a serverless application that runs on an AWS Lambda function that is attached to a VPC. The company needs to integrate the application with a new service from an external provider. The external provider supports only requests that come from public IPv4 addresses that are in an allow list. The company must provide a single public IP address to the external provider before the application can start using the new service. Which solution will give the application the ability to access the new service? Option A. Deploy a NAT gateway. Associate an elastic IP address with the NAT gateway. Configure the VPC to use the NAT gateway. This solution involves deploying a NAT gateway within the VPC. A NAT gateway allows resources within a private subnet to initiate outbound traffic to the internet while preventing inbound traffic from directly reaching those resources. By associating an elastic IP address with the NAT gateway, you ensure that the outbound traffic appears to come from a specific public IP address. This elastic IP address can then be provided to the external service provider for whitelisting. Configuring the VPC to use the NAT gateway ensures that outbound traffic from resources within the VPC, such as Lambda function, is routed through the NAT gateway. So this one seems to be the correct answer, but let's discuss available options as well. Option B. Deploy an egress-only internet gateway. Associate an elastic IP address with the egress-only internet gateway. Configure the elastic network interface on the Lambda function to use the egress-only internet gateway. An egress-only internet gateway is used for IPv6 traffic and is specifically designed to allow outbound communication from instances in a private subnet to the internet while preventing inbound traffic. It does not provide the ability to specify a public IPv4 address for outbound traffic or to associate an elastic IP address with it. So this one is not the correct answer. Option C. Deploy an internet gateway. Associate an elastic IP address with the internet gateway. Configure the Lambda function to use the internet gateway. Deploying an internet gateway and associating an elastic IP address with it would provide internet access to resources within the VPC. However, this solution does not provide a way to specify a single public IPv4 address for outbound traffic, which is required by the external service provider. So this is not the correct answer. Option D. Deploy an internet gateway. Associate an elastic IP address with the internet gateway. Configure the default route in the public VPC route table to use the internet gateway. Configuring the default route in the public VPC route table to use the internet gateway would provide internet access to resources within the VPC. However, it does not provide a way to specify a single public IPv4 address for outbound traffic as required by the external service provider. So, the correct answer is Option A. Deploy a NAT gateway, associate an elastic IP address with the NAT gateway, configure the VPC to use the NAT gateway. Question number 4. A company wants to run a custom network analysis software package to inspect traffic as traffic leaves and enters a VPC. The company has deployed the solution by using AWS CloudFormation on 3 Amazon EC2 instances in an auto-scaling group. All network routing has been established to direct traffic to the EC2 instances. Whenever the analysis software stops working, the auto-scaling group replaces an instance. The network routes are not updated when the instance replacement occurs. Which combination of steps will resolve this issue? Choose 3 answers. Option A. Create alarms based on EC2 status check metrics that will cause the auto-scaling group to replace the failed instance. This option ensures that when an EC2 instance fails the status check, the auto-scaling group automatically replaces it. While this helps with instance replacement, it does not address the issue of updating network routes. Option B. Update the CloudFormation template to install the Amazon CloudWatch agent on the EC2 instances. Configure the CloudWatch agent to send process metrics for the application. Option C. Update the CloudFormation template to install AWS System Manager agent on the EC2 instances. Configure System Manager agent to send process metrics for the application. Option B and C focus on monitoring and application processes running on the EC2 instances. While monitoring is important for detecting failures, these options do not directly address the issue of updating network routes. So option B and C are not the correct answer. Option D. Create an alarm for the custom metric in Amazon CloudWatch for the failure scenarios. Configure the alarm to publish a message to an Amazon Simple Notification Service topic. This option involves creating an alarm for a custom metric that monitors the health of the network analysis software. When a failure occurs, the alarm publishes a message to an SNS topic indicating the failure. Option E. Create an AWS Lambda function that responds to the Amazon Simple Notification Service message to take the instance out of service, update the network routes to point to the replacement instance. This option suggests using a Lambda function triggered by the SNS message to take the failed instance out of service and update the network routes to point to the replacement instance. This addresses the issue directly by automating the process of updating network routes. Option F. In the CloudFormation template, write a condition that updates the network routes when a replacement instance is launched. This option involves updating the CloudFormation template to include the logic that updates network routes when a replacement instance is launched. While this can be effective, it may require complex scripting and logic in the CloudFormation template. Given the requirement to update network routes when an instance is replaced, the most suitable combination of steps would be option A, D, and E. These steps ensure that instances are replaced when necessary and the network routes are updated accordingly to maintain continuous traffic flow. Alright, so this is it for today. Thank you all for attending today's class at 591 Lab. We hope you found the material informative and helpful. Remember, practice is critical to mastering any new skill, so review the course content and keep practicing with 591 Lab help and support. If you have any questions or concerns, please don't hesitate to contact us. We appreciate your participation and look forward to seeing you in our future classes. I would like to request you to subscribe to our channel, give this video a thumbs up and hit the bell icon. Your support empowers us to produce more valuable content like this. Have a great day.